Have you ever, stopped and wondered what makes your favorite apps just work all the time? Like streaming services, online shops, how do they handle millions of people suddenly logging on or roll out updates without crashing? It feels a bit like magic sometimes, doesn't it? But it's not magic. There's this incredibly powerful engine humming away underneath it all. And today, that's exactly what we're diving into, Kubernetes. You might hear it called K8 sometimes. We've gathered some really great sources, and our mission for this deep dive is basically to unpack them for you. We want to give you a really clear picture of what Kubernetes actually is, why it's become so central to tech today, and how it's used everywhere.
That's it, exactly. And the goal isn't just a definition. We're trying to pull out the key insights from everything we've looked at, really give you a shortcut to understanding this, well, this foundational piece of cloud native technology. By the time we're done here, you should really get not just the what, but the why. Why Kubernetes is so critical for building those apps. We all rely on the ones that need to be reliable and scale up instantly.
Okay, let's get into it then. Kubernetes, K8s. If someone's heard the name, maybe seen it mentioned, but isn't totally sure, what is it? What's its main job? And maybe just as important, what problems does it actually solve?
Yeah, good place to start. So fundamentally, our sources all point to Kubernetes as an open source platform. Its whole purpose is automating how you deploy, scale, and manage applications that are containerized. Now, containerized, let's quickly touch on that. Think of a container like a standard box. It packs up an application with everything it needs, the code, libraries, all the dependencies. This means it runs the same no matter where you put it. Kubernetes then acts like the conductor for all these boxes, these containers.
The conductor for these self-contained app packages. Okay, but why did it get so huge? Why is everyone using it?
Well, that's the really interesting part, isn't it? It became so dominant because it tackles the sheer complexity of running modern software, especially software built as microservices. Imagine trying to manually keep track of like hundreds, maybe thousands of tiny, separate containerized services. It'd be an operational nightmare.
I could only imagine.
Exactly. Kubernetes just simplifies all that. It's the orchestrator. It automates the tricky stuff, figuring out which machines containers should run on, handling how they talk to each other, balancing the load. It even automatically deals with failures. That's huge.
And looking through the sources, they really highlight some key strengths. It's pretty impressive when you list them out. What are those core capabilities that make it so indispensable?
Absolutely. Let's break those down. First, automation. This is massive. It cuts down so much manual work. Deploying apps, scaling them up or down, handling updates, it automates that. Then, portability. This is key. Your Kubernetes apps will run the same way, whether they're in your own data center, on AWS, Google Cloud, Azure, or some mix.
So you avoid getting stuck with one cloud provider.
Precisely. That's a major strategic win for businesses. No vendor lock-in. Next, scalability. Kubernetes can automatically adjust how many resources your app is using based on the current load. So big traffic spike. It spins up more instances, traffic dies down, it scales back, saves money, handles demand, and, crucially, resilience. If a container crashes or even a whole machine goes down, Kubernetes notices and automatically replaces or reschedules those containers onto healthy machines.
So it keeps things running?
It keeps things running, yeah.
Yeah.
Your services stay available. And finally, efficiency. It's smart about packing containers onto your machines, making sure you're getting the most bang for your buck from your infrastructure.
When you put all those together,
Yeah.
automation, portability, scalability, resilience, efficiency, you really see how it tackles the big headaches of managing modern distributed apps. It's easy to see why it's called a cornerstone of cloud-native development. Just takes away so much of the pain.
Exactly right. It lets development teams actually focus on building cool features instead of wrestling with the underlying infrastructure all day.
Okay, and just to set the stage for what's coming next, maybe we should quickly name the main building blocks, the core concepts you hear about with Kubernetes.
Good idea. So the basic pieces are pods. These are the smallest things you deploy. They hold one or more containers. Nodes. These are the machines, physical servers, or virtual machines where your pods actually run. A cluster is just a group of these nodes, all managed by Kubernetes. The control plane is like the brain. It manages the whole cluster, makes decisions, keeps track of everything. Deployments. These define how you want your application to run and how updates should be rolled out. And finally, services. These provide stable network endpoints so different parts of your application can reliably communicate, even when pods are being created or destroyed. Think of them as stable addresses.
Got it. Pods, nodes, cluster, control plane, deployments, services, the building blocks. Okay, so with that foundation laid, let's talk about where Kubernetes actually gets used, the real-world applications. Its versatility is pretty amazing, right? It pops up in all sorts of industries and for different kinds of apps. Understanding these use cases really shows its power.
Absolutely. That flexibility is why it's such a good fit. Whenever you need things to scale reliably, stay highly available, and run anywhere. It's not just for one type of problem.
So let's get specific. Where does it make a big impact? Maybe start with microservices architectures. Seems like a natural fit.
Oh, completely. Microservices, breaking down big apps into small, independent services, talking over APIs. Managing dozens or hundreds of those manually would be just chaos. Finding services, scaling them individually, handling failures.
A nightmare, like you said.
Exactly. And this is where Kubernetes is just brilliant. Our sources show how it turns that potential chaos into something automated, almost invisible. It handles service discovery, how services find each other, load balancing between instances of a service, scaling just the parts that need it. One example from the sources was this major e-commerce site. They cut their peak traffic infrastructure costs by almost 40%.
Well,
Yeah, and they achieved zero downtime during massive sales events, all because Kubernetes was automatically managing the scaling and recovery of all their little services, login, catalog, payments, everything.
that's a tangible benefit. Okay, what about automating the whole development process? Continuous integration, continuous deployment CI/CD.
Right, CI/CD. Automating the build, test, deploy cycle. Traditionally, deploying updates, especially for big apps, often meant scheduled downtime. Annoying for users, stressful for teams.
Definitely been there.
Kubernetes really changes the game here. It has built-in support for rolling updates, so you can deploy new versions of your app gradually without taking the whole thing offline. Zero downtime deployments. Plus, it plugs right into CI/CD tools people already use, like Jenkins or GitLab. Teams can push out updates multiple times a day. One SaaS company in our sources went from these huge, stressful quarterly releases to deploying updates whenever they were ready, sometimes many times a day. Kubernetes handles the rollout, and if something goes wrong, it can automatically roll back.
That speed must make a huge difference to how fast they can innovate. Okay, next up, cloud-native applications. Apps built for the cloud. How does K8s fit there?
Well, cloud-native apps are designed to take advantage of the cloud's flexibility and scale. But, different clouds, AWS, Azure, Google Cloud, they all do things slightly differently. You can get locked in.
The portability point again.
Exactly. Kubernetes gives you that consistent layer across clouds. Design once, run anywhere. Plus, its auto-scaling is perfect for the cloud, handling those sudden traffic surges you get. Think about a big streaming service launching a hit show. Before Kubernetes, handling millions logging in at once meant frantic manual work, maybe even crashes.
Suffering.
The worst. The absolute worst. Kubernetes automates that scaling. It just adds resources when needed, removes them when not. Our sources mentioned one service that now handles demand spikes 10 times their normal load, all managed by Kubernetes totally automatically. Viewers get a smooth experience.
That's seriously impressive. Okay, different direction. Heavy-duty tasks like machine learning and data processing. Seems like managing those resources would be tricky.
Extremely tricky. Training ML models, running big data jobs, they chew up CPU and memory like crazy. Provisioning those resources efficiently, making sure you're not wasting money, releasing them promptly, it's complex.
So Kubernetes helps manage the hardware demands.
Precisely. It's great at managing these resource-hungry workloads. It can spread the work across your cluster, scale the resources up for a big job, then scale them right back down. It also works really well with tools like TensorFlow or Spark. So a data science team can just submit their training job to the Kubernetes cluster. Kubernetes figures out the resources, scales them as needed, gets the job done, and then releases everything. It optimizes the whole process.
Okay, another big one. Hybrid and multi-cloud. Running apps both in your own data center and in the cloud or across multiple clouds. Why Kubernetes?
The challenge there is consistency, right? How do you manage applications smoothly when they're running in different places, maybe with different underlying tech?
Yeah, sounds complicated.
Kubernetes portability is the key again. It provides that uniform operating environment. Move apps between your data center and the cloud, or between AWS and Azure without rewriting them. This avoids vendor lock-in, lets you use the best tool for the job, maybe keep sensitive data on-prem. We saw an example of a bank. They run their main app on premises for compliance reasons. But when transaction volumes spike, they use Kubernetes to seamlessly burst some of that workload out to a public cloud for extra capacity. Best of both worlds, managed consistently.
Very clever. And finally, a critical one. High availability and disaster recovery. Keeping things online no matter what.
Yeah, this is fundamental. Getting that 5 nines, 99.999% uptime used to require incredibly complex bespoke setups. Kubernetes has self-healing built right in. A pod fails, Kubernetes replaces it, a whole server dies, Kubernetes reschedules its workloads onto healthy ones. It's always working to maintain the desired state you define.
So it's automatically resilient.
Highly resilient, yes. And it supports multi-region setups too, so you can run your app across different physical locations for serious disaster recovery. Think about your online banking app. It has to be up. Kubernetes is often working behind the scenes, automatically handling failures, maintaining that uptime, protecting against major outages, often without anyone needing to intervene manually.
So when you step back and look at all these use cases, what does it really mean for you listening to this? It means Kubernetes is this invisible powerhouse behind so many of the services you rely on every day. It's the unsung hero making sure things are reliable, scalable, and just work. But Kubernetes itself, the core platform, that's not the whole story, is it? A huge part of its power comes from the ecosystem around it.
Absolutely. The core is powerful, but the ecosystem of tools and integrations is what makes it so incredibly versatile and adaptable. It's like having a basic toolkit versus a massive workshop full of specialized gear. Understanding that ecosystem really helps you see how Kubernetes fits into the bigger picture of software development and operations today.
Right. Our sources mention some basics you absolutely need, like container runtimes, the things that actually run the containers. Docker's famous, but there are others like Containered or CRIO, sometimes chosen for performance.
Yep. And container registries, places to store and share your container images, like Docker Hub or Google's GCR.
And the command line tool, Kubectl. That's essential for actually talking to your Kubernetes cluster, right?
Oh yeah, Kubectl is your primary interface for managing clusters day to day. Deploying apps, checking logs, managing resources, you do it all through Kubectl. Then, building on those basics, you get into specialized tools. For orchestration and management, things like Helm and Customize are super popular. Helm is like a package manager. It uses these things called charts, basically templates, to deploy complex applications easily, makes sharing and managing apps much simpler.
And Customize.
Customize lets you tweak your configurations for different environments, say development versus production, without messing with templates. It's built right into Kubectl now, which is handy.
Okay, what about networking? All those microservices need to talk to each other securely and reliably.
That's where service meshes come in. Istio is a really powerful one. It creates a dedicated layer on top of your network to manage traffic between services, enforce security policies, give you visibility, all without changing your app code. And then there's Cilium. It uses some advanced Linux kernel tech called eBPF to provide really high-performance networking and security. It's great for demanding workloads.
Makes sense, and for keeping an eye on everything monitoring and logging.
Essential. Prometheus is kind of the standard for collecting metrics, CPU usage, memory, request counts, all that. Then you often use Grafana to visualize those Prometheus metrics on nice dashboards, see at a glance how things are doing, and for logs, figuring out what went wrong, or just tracking events, the EFK or ELK stack is common. That's Elasticsearch for searching logs, Fluent or Logstash for collecting them, and Kibana for visualizing them.
Right, and how does this all plug into CI/CD pipelines?
Well, Jenkins is still a workhorse for automating build and deployment pipelines that target Kubernetes. But there's also a newer approach called GitOps, and tools like Argo CD are really popular there. Argo CD basically watches your Git repository and makes sure your cluster always matches what's defined in your code. It's continuous delivery based on Git.
Interesting. And storage. Containers are often temporary, but apps need data to persist.
Big challenge. Rook is pretty cool. It lets Kubernetes manage distributed storage systems like Ceph directly inside the cluster, so your storage becomes part of the orchestrated environment. More fundamentally, Kubernetes has its own way of handling storage called persistent volumes. This lets your pods connect to various types of storage, cloud, disks, network shares, whatever, in a consistent way.
And wrapping up the ecosystem towards security. Always critical.
Absolutely. OPA, the Open Policy Agent, is a big one. It lets you write and enforce custom policies across your cluster, like don't allow containers to run as root, or only allow images from trusted registries. And Falco acts like a runtime security guard. It watches for suspicious behavior inside your running containers and nodes unexpected file changes, network connections, command executions, and alerts you.
Wow, that's a lot of tools. And you see Kubernetes offered everywhere too, right?
Yeah.
All the major clouds have managed versions, AWS EKS, Google GKE, as your AKS.
Exactly. Those managed services take away a lot of the operational burden of running the control plane yourself, makes it easier to get started. Plus, you have platforms like OpenShift and Rancher for on-premises or hybrid setups.
It really feels like a huge active space.
It really is. The community around Kubernetes is massive, thousands of people contributing. The Cloud Native Computing Foundation, the CNCF, provides stewardship for Kubernetes and many of those ecosystem projects we mentioned. That fosters innovation. And because it's open source, you can even extend Kubernetes itself with custom resource definitions, CRDs, to manage totally custom things specific to your business. It's incredibly powerful and adaptable.
So let's pull this all together. We've gone from the basics, what Kubernetes is, why it's so important, through all those diverse ways it's used in the real world, and finally touched on that vast ecosystem of tools that extends its capabilities. Hopefully this deep dive has given you, our listener, a much clearer, more practical understanding of Kubernetes and its impact.
Yeah, the key takeaway is that Kubernetes is this incredibly powerful, adaptable platform for running containerized applications. Microservices, CI/CD, ML, high availability, it can handle so much. And if you're looking to get started, really digging into those core concepts we talked about, pods, services, deployments, and maybe playing with tools like Kubectl and Helm, that's a great path to unlocking its potential.
Definitely gives you a lot to think about regarding how modern software is built and run.
And maybe leaves us with a question to ponder. As this Kubernetes ecosystem keeps growing and evolving, adding more power and features, how do we balance that drive for innovation with the increasing operational complexity that comes with managing all these sophisticated tools and capabilities? That's a key challenge ahead.